Okay, looking at question 6 of the 2023 SACE Stage 2 General Math exam, you can see it's another finance question. This one was a little bit longer, over 3 pages, and it also involved an offset question. So let's get straight into it. Grace took out a home loan of $356,000 over 25 years with an interest rate of 5.11%, with interest being compounded monthly. Show that Grace would pay approximately $2,100 per month in loan repayment. So if you head into your finance function here on your graphics calculator, we're looking at compound interest, so F2. These are the values that we need to show in terms of our working out. So for N remember is the number of periods of the loan. So the loan is 25 years and Grace is making monthly repayments. So N is equal to 25 times 12 or 300. I is equal to 5.11%. Now, no need to change that to a decimal when you're using a graphics calculator, so just type it in as it is. Present value is the principal or the amount she borrows, so $356,000. Now, that's a positive because it's an incoming. She's borrowing that. She is receiving that from the bank, so keep that as a positive amount. PMT is what we're trying to work out here. Again, it should be close to $2,100. The future value should be set to 0 because Grace will be looking to pay off that loan completely over the 25 years. Now, PY and CY. PY, in this case, payments per year is going to be 12 because we're looking at monthly repayments. And CY, compound periods per year, will also be 12 because it tells us that compound or interest is being compounded monthly rather. So F4 will tell us PMT, which in this case works out to $2,104.02. Now, really importantly here, you always round up to the next cent when you're calculating PMT. I know the third decimal point here is a 9, so we'd round up anyway. But in any case, if it was a 1, 2, 3, or 4, we would still round up because we want to make sure we can pay that loan off completely over the number of years of that loan, in this case 25. Okay, moving on to the next part of the question. It says to calculate the total interest that Grace would be expected to pay for the 25-year loan. Now, interest on the loan is equal to her total repayments minus the amount she borrowed, okay, or the principal. So Grace, remember, is making 300 payments, or 25 times 12, of $2,104.02. Okay, so that's her total repayments. And we're going to subtract that from the amount she borrowed, or the principal, remember, which was $356,000. Now, I've done that calculation. It works out to be $275,206. The other way of doing this is to use the amortization function on the graphics calculator. So if you have a look over here, if you press F4, with all those values remaining the same, and set PM1 as the first period of that loan, so the first month, and PM2, in this case, because we're looking for the entirety of interest over the 25 years, set it as the last period of that loan, so 300. And then you press F4 to tell you the total sum of all the interest, which is very close to the amount we worked out there. It's only 6 cents off if you round that up. Either of those is fine. For the working out, if you are using amortization, you just have to show what values you're putting in terms of PM1 and PM2. Okay, so that's really important to show that working out if you are using the amortization function. Now, before I move on to the next part of the question, really quickly, if you were unable to get this answer in part AI, you could use the $2,100 in part AII instead of the exact amount that I've used here. Okay, so either would be acceptable. All right, moving on to the next part of this question. It says to state 2 reasons why your solution to part AII, so this answer we just worked out of $275,206 in interest, could be considered unreasonable. Well, first of all, obviously, interest rates generally change. So it could be expected that the interest rates are likely to change over the 25 years. I think the other big thing here is that when I say she, Grace could be looking at some loan minimization strategies. So when she could afford to, she might, pay off more than the minimum $2,104.02 per month. So Grace could make larger repayments per month. There are a lot of different interest minimization strategies. Obviously, she could pay more frequently, so fortnightly or weekly instead of monthly. Another one is she could use an offset account. So Grace could use an offset account, okay, which would reduce the amount of interest she would be paying. Anyway, we'll look at that in a minute. Part B says to show the remaining balance of the loan after 3 years is approximately $333,000. So again, we're going to use the compound interest section of our graphics calculator here. We're going to set n to 3 times 12 because we're talking about the first 3 years. So 3 times 12 or 36. The interest rate, again, we're just assuming remains at 5.11%. It hasn't changed. Present value is also going to remain at $356,000. PMT is going to be what we worked out before, so the minus $2,104.02, and that is a minus because it's an outgoing. Grace is paying that to the bank, so PMT negative $2,104.02, and the future value is what we're trying to work out here. Payments per year, again, we're assuming they remain as 12, likewise with the compound periods per year. So based on all that, let's calculate the future value. We'll press F5. Tells us that Grace still has remaining on her loan after 3 years of payments, $333,173.60. Okay, moving on to the next part of the question. At this time, so 3 years after the start of the loan, Grace won $50,000 in a lottery. She has the option to immediately deposit the $50,000 in an offset account linked to her home loan where it will stay for exactly 4 years. So it says to state the new balance that interest will be calculated on as soon as the $50,000 is deposited into the offset account. Remember, putting money into an offset account, you're not paying it off the loan, but it reduces the balance on which you are charged interest on, okay? So the amount she still has left in her or on her loan after 3 years of payments is $333,173.60. We're going to subtract the amount of money she has in the offset account, and that is going to be the balance that she's charged interest on, which works out to be $283,173.60. Part C II says to calculate the remaining balance after 4 years, assuming that payments do not change, and the full $50,000 remains in the offset account. So, again, back into the finance function here. N is now going to be 4 times 12 because we're looking at that money staying in for exactly 4 years, okay, from the question above. Interest rate is again, see, 5.11%. The present value, so at the moment, what she's being charged interest on is what we just calculated here in the first part of this question. So that is $283,173.60. The PMT, we assume, is unchanged. So let's change some of these values as we go. Sorry, so this will be 4 times 12 now, or 48. 5.11 for the interest rate. Present value is $283,173.60. PMT remains the same. Future value is what we're trying to work out, so we can just reset that for now. So future value is what we're trying to work out. PY is 12 and CY is also 12. So the future value after 4 years of that money being in the offset account will be, the new balance on her loan is $235,451.33 still to pay off her loan. Plus, remember, she still has to pay that $50,000 off the loan as well. She's just got that sitting in an offset account at the moment, but she hasn't paid it off the loan. All right, moving on to Part C, III, says to calculate the interest saved over the duration of the loan by placing the $50,000 in the offset account for the 4 years. This is probably the tricky part of this question. Now, there are multiple ways of doing this. I think the more common way of doing is to work out how much time she saves by using the offset account, and then using that amount to work out how much interest she would save. Okay, remember, with no offset account, she was paying it off over 25 years. So with no offset account, N is equal to 300, or 25 times 12. So she's making 300 repayments of $2,104.02. Okay, how many months is she saving by using this offset account? Okay, so this is where we're going to work out N. So N is now what we're trying to solve for. So let's head back in. Let's reset N. Interest rate, we're assuming, remains at 5.11%. The present value now, to get your head around this, it needs to be this amount we just worked out. That's how much she has left to pay off the loan. So she still has on the loan account $235,451.33. But keep in mind, she still needs to pay off that $50,000, which is now no longer in that offset account. Doesn't tell us that she's taken it out, but they were very concise with their questioning up here. It says it's going to stay for exactly 4 years. Okay, so we're assuming now it's come out. So that is the present value. That's really important to get right there. Now, the PMT, again, we're assuming that doesn't change. So keep it as minus $2,104.02. The future value, we're going to set to 0 here. So to pay off the loan completely, how long is it going to take her? Now, PY and CY, we're assuming, are both still 12. Okay. Based on all that, what is N equal to? How many more months does Grace have to pay off this amount? Keeping in mind she has already been paying it off for 7 years. Okay. So let's pop these amounts in. So it's $235,451.33 plus the $50,000. PMT remains unchanged. The future value we want to set to 0, and PY and CY are both 12 still. So how many more months does it take Grace to pay off that loan? It takes approximately 202.9 months. Now remember, she's been paying it off already for 7 years. So we're going to add 7 times 12, okay, to give us how many months in total Grace will pay off the loan with this offset account situation, okay, which works out to be 286.9 months, okay, which means in total, how many months has she saved? So months saved, originally without the offset, it was 300. We're going to take 286.9, which gives us 13.1 months saved. And the question actually asks the total interest saved. So we actually need to, convert this to a dollar amount. So every month she's paying $2,104.02. If she doesn't have to pay that for 13.1 months because she's saved that, then the amount of interest she saved is $13.1 times by $2,104.02. Now that works out to be $27,562.66. Okay, so you can see she saved a considerable amount of money in interest from having that $50,000 in the offset account for those 4 years. Okay, let's move on to the next part of the question. The last page of this one anyway. It says a friend suggested that Grace should instead invest the $50,000 in an investment account with a return of 4.79% per annum, which is this time compounded fortnightly. It says to show that the balance of the investment after 4 years is approximately $60,500. So N is now going to be 4 times 26 because we're looking at fortnightly payments for 4 years. So let's go back in and set that. So 4 times 26 The interest rate here is 4.79. So let's set that. The present value, the principal, the amount she's investing is 50,000. Now we're going to set this as a negative because it's an outgoing. She is putting it into the bank, or she's giving it to the bank for those 4 years. So minus 50,000 is the investment. PMT. Now, is she making any regular repayments? It doesn't tell us, so we assume that's going to be 0. Okay, the future value is what we're trying to work out here. And remember, it should be close to 60,500. Now, PY and CY are both going to be set to 26. Obviously, compound periods per year is 26 because it tells us that in the question. And we're assuming then that compound interest is paid into the account every fortnight as well, okay? So set those values to 26. If you change PY to 26, it'll automatically change CY to 26 as well. And here we're trying to work out the future value, which is exactly $60,548.62. So that's how much she'll have in her account after 4 years. The question then says, hence calculate the interest earned on the investment over the 4 years. So the interest is going to be obviously the amount she has in the account now, which is $60,548.62, minus the initial amount she invested, which is the 50,000. So in total, she has earned $10,548.62 in interest over the 4 years based on this scenario. It says Grace has a marginal tax rate of 37%. Calculate the total tax to be paid on the 4-year investment. It says here as well, assume the tax is only paid once at the end of the investment. So really all we need to do is work out 37% of 10,548.62. Mathematically, that means 0.37 times by 10,548.62. Now that works out to be, excuse me, $3,902.99. So that's how much tax she has to pay, almost $4,000 from that $10,500 that she's earned. Okay, so realistically, she's kind of really only earning $6,500 over those 4 years, which I mean is still pretty good, but it's not as good as the amount of money she was saving by putting that money in the offset account for 4 years, was it? Right, and that's the next part of the question. It says, with reference to your solutions from part C and D, which option would be better for Grace? Tick the appropriate box to indicate your answer and provide 2 financial reasons to support your answer. Well, obviously, as we just said, the offset account is better. Firstly, she does not have to pay tax on money in that offset account. So no tax payable on that money in the offset account, as opposed to paying nearly $4,000 on the interest that she earned in the investment account. And I guess there are a few solutions here, but if we can actually compare the amounts, so with the offset account, Grace saved $27,562.66 compared to only earning, $10,548.62 in the investment. Which, remember, also reduced after she had to pay tax anyway. Other things I think that Massa and the SACE board have come out and said as well is, in terms of possible solutions here, is that the offset account has a higher rate of interest compared to the savings account. And another one here is that she still has access to all funds in the offset account in case of an emergency. So yeah, offset accounts are great because you can still access that money at any time. And some of those investment accounts, your money's sort of locked in for the period. In this case, it was 4 years. So that's it for question 6 in the exam from 2023. Hopefully that helps, and all the best with your study, guys.